Good evening. This is Miss Foster, your geometry teacher. I hope that the first day went well for you guys. I hope that everybody's doing okay at home. I know that can be weird because you don't have my wonderful self to talk to. But I'm here for you if you need anything. Just please email me and I'll try to get back with you at like 1 or at 8. That's kind of my plan because I have the kids all day long. So anyway, today we're actually skipping 9-4. That was a lesson about rotating about other fixed points. We're not going to do that. So if you go to page 16 of your packet, you can scratch that off. Scratch that off on page 17. And you're starting with me on page 20. On the bottom, it says page 20 right there. All right. Dilations. A dilation is an enlargement or a reduction. The perfect example of when you dilate something is if you blew it up at like a print shop. That's an enlargement. And it's a dilation. It's still the same thing, it's just bigger. It's the same shape. A dilation is an enlargement or a reduction of a figure with respect to a fixed point called the center of dilation. Okay, a dilation is an example of a non-rigid motion in that it does not preserve congruency. So what basically that means is that you're not taking the same exact thing and rotating it or reflecting it or shifting it. You're taking an object and changing its size. So it's not going to be a congruent object that you end up with. That's what non-rigid means. The rigid ones were the translations, the reflections, and the rotations. And we've already covered those 3 things. Those were rigid. So take some time and write all this down. If you're behind, just hit pause and then come back to me. A dilation produces similar figures. Not congruent, but similar figures. We haven't done the unit on similar figures yet, but I think that we can still do this because I think you're pretty smart and you'll figure this out. All corresponding angles are the same, which is congruent. And then all corresponding sides are what we call proportional. Proportional means that, like, if one of them is 2 inches and the other one is 4 inches, then another side of the object, 3 inches, would have to match up with a 6-inch side. Because if that's double that, then that's got to be double that. So they're all in this is called a proportional relationship. And you've seen that a lot in your past, like pre-algebra and 7th and 8th grade math. You did a lot with proportion. You remember cross multiplying? That's what that was all about. Okay, scale factor. The scale factor indicates how much the figure will enlarge or reduce. Variable for scale factor is commonly K. You know how we have a variable for stuff? Well, that's the one we're going to use when we're talking about dilations. When K is greater than 1, the dilation would be an enlargement. If K was less than 1, which still positive, we're not talking about negative stuff, like 1/2, 1/4, the dilation is a shrinking. or a reduction. That would shrink up the object. Honey, I Shrunk the Kids. That was a movie in the 90s. You need to watch it. It was really good. Of course, like the graphics or whatever are pretty lame because it was in the 90s, but it's a really fun movie. Okay. Dilation rule. If PXY is a pre-image point, then its image, which is after the transformation has occurred and you dilated it, would now be K times X, K times Y. The new point. This would be the image. So all of the points of the pre-image get multiplied by K on the X and K on the Y. So we're going to do, the origin is the center of dilation on all of the ones that we're doing. And I'll explain what that means in a second. But first, go ahead and plot triangle RST.